Imagine standing at the edge of something enormous without quite being able to see where it ends. No map in your hands, no timestamp to anchor you, just a vast and quiet landscape stretching out in every direction. Cold air pressing against your face, and somewhere out there, in the caves and rock shelters and open valleys, the last members of a human species going about their lives without any idea they are the last. The fire is still burning, the tools are still being made, and then, slowly, in ways we're still trying to understand, they are gone. That disappearance is what we're here to explore tonight. Somewhere between 40 and 28,000 years ago, give or take the considerable uncertainties that always shadow ancient dates, the Neanderthals ceased to exist as a distinct species. They had been here for at least 200,000 years, possibly longer. They had survived ice ages and warm interglacials, volcanic winters, shifting coastlines, and every challenge the Pleistocene world could arrange. And then, within what is geologically a very brief window, they vanished from the fossil record. No more bones, no more distinctly Neanderthal tools, a silence where there had been something. But here is where the story immediately gets complicated, and where it gets interesting. Those dates are genuinely hard to pin down. Radiocarbon dating, the primary tool researchers use for this period, becomes increasingly imprecise as you push back beyond 30,000 years. Contamination of ancient bone samples with younger organic material can make something seem more recent than it actually is, and for a long time this led to claims of very late surviving Neanderthal populations that more rigorous testing has since revised. The site of Vindija Cave in Croatia, once thought to hold Neanderthal remains as young as 28,000 years, has been redated to somewhere around 40,000 years with better methods. Every time the science sharpens, the dates tend to pull back a little further, and the apparent overlap between Neanderthals and modern humans in Europe grows shorter and more uncertain. So when you hear a specific date, it's worth holding it loosely, as a best current estimate rather than a fixed fact. The evidence we have comes from several directions at once, and each direction tells us something different and incomplete. Bones tell us where Neanderthals lived, and roughly when, what they ate, and how their bodies were stressed, what injuries they survived and which ones they didn't. But bones are rare, fragmentary, and unevenly preserved. We are reconstructing an entire human experience from scraps. Stone tools extend the picture somewhat, because tools survive better than bone and spread across a wider geography. The Mousterian technology associated with Neanderthals and the later Châtelperronian industry that may reflect a period of contact and exchange with arriving modern humans gives us a kind of cultural fingerprint to follow through layers of sediment. But tools don't come with name tags, and arguments about who made what continue among researchers. Climate records, drawn from ice cores, ocean sediments, and pollen sequences, give us the environmental backdrop, the temperature swings and habitat shifts that shaped every living thing in Europe and Western Asia during this period. They can tell us when the cold tightened its grip and when forests retreated and when the landscape fractured into isolated refugia. Climate doesn't explain everything, but it sets the stage. And then there is ancient DNA, perhaps the most quietly revolutionary tool to arrive in this field in recent decades. Genetic analysis has told us things no bone or tool ever could, that Neanderthals and modern humans interbred, that their genetic material lives on in most people alive today outside of sub-Saharan Africa, that their story did not simply end but wove itself into our own. This is not a footnote. It changes the meaning of the word disappearance, because disappearance might not mean extinction in the way we usually imagine it. It might mean absorption, a gradual blending into the expanding population of Homo sapiens until the distinct Neanderthal line dissolved into something shared. It might mean fragmentation, with isolated groups surviving in different places at different times, some lasting longer than others, their endings scattered and asynchronous rather than simultaneous. It might mean a series of local extinctions playing out across Europe and Western Asia over thousands of years, with no single catastrophic moment, no last stand, just a slow and unwitnessed fading. The question of what happened to the Neanderthals is really several questions layered on top of each other. It asks about climate and ecology. It asks about population size and genetic vulnerability. It asks about the arrival of a new species with different capabilities, different networks, different ways of moving through the world. It asks about disease, about competition, about chance. And it asks about what we mean when we say one species ends and another continues. Tonight we're going to sit with all of those questions gently. There's no single satisfying answer waiting at the end, and that's all right. The story is richer for its uncertainty. The Neanderthals lived complex lives in a complex world, and they deserve a telling that doesn't flatten them into a simple, cautionary tale or a footnote in our own origin story. So wherever you are right now, whether it's late at night with the house finally quiet, or early morning before anyone else is awake, or somewhere in the middle of a restless night when sleep won't quite come, I'd love to know. Leave a comment if you feel like it. Tell me where you're listening from and what time it is there. There's something lovely about knowing that people all over the world are settling in with the same quiet curiosity, all wondering together about people who lived and breathed and disappeared long before any of us were here to ask why. They were not our ancestors in the direct sense, and they were not simply a primitive version of us. That distinction matters, and it's worth settling into before we go any further. Neanderthals were a separate human lineage, a distinct branch on the family tree that diverged from the ancestors of modern Homo sapiens, somewhere between 400,000 and 800,000 years ago, depending on which evidence you lean toward and which part of the genome you look at. The exact timing remains an open question, one of many in this field where the honest answer involves a range rather than a fixed point. What's clear is that they were their own thing, shaped by their own long evolutionary history, adapted to their own particular corner of the Pleistocene world. The word species is useful here, but it's also a little slippery, and it's worth pausing on it. In everyday language, species implies a clean boundary, two groups that cannot or do not produce fertile offspring together. But biology tends to resist clean boundaries, especially among closely related populations that have only recently diverged in evolutionary terms. We now know, thanks to ancient DNA, that Neanderthals and modern humans did interbreed, and did so more than once, in more than one place, producing offspring who went on to have children of their own. That is not what you expect from two groups that are truly and completely separate species, and yet they were different enough genetically and anatomically and behaviourally that most researchers still treat them as distinct. The label is a convenience, a shorthand for a real and significant difference, even if the edges of that difference were blurrier than a textbook diagram might suggest. Geographically, Neanderthals ranged across an enormous territory. Their remains and their tools have been found from Portugal in the west to Siberia in the east, from the southern coastlines of the Mediterranean to the cold northern edges of habitable Europe. Sites in Spain, France, Germany, Italy, Croatia, Greece, Iraq, Israel, Uzbekistan, and beyond all carry their signature, in bone or in stone or both. They were not confined to a single refuge or a narrow ecological niche. Over hundreds of thousands of years they moved through and inhabited a vast sweep of the old world, adapting to an enormous variety of environments along the way, and that adaptability shows in their bodies. Neanderthal anatomy is immediately recognizable once you know what to look for. The skull is long and low rather than tall and rounded, with a prominent brow ridge sweeping across the forehead and a distinctive occipital bun, a rounded protrusion at the back of the skull that gives the head a shape quite different from our own. The face projects forward, with large nasal passages that some researchers believe were an adaptation for warming and humidifying cold, dry air before it reached the lungs. The cheekbones sweep back rather than projecting forward in the way ours do, and the chin is typically absent or weakly defined, another contrast with modern humans whose chins are something of an anatomical peculiarity. Below the neck, Neanderthals were broad and robust in ways that speak directly to the environments they inhabited. Their bodies were compact, their limbs relatively short in proportion to their torsos, a shape that conserves body heat in cold climates. This follows a biological pattern called Bergmann's rule and Allen's rule, which describe how mammals in cold environments tend to evolve bulkier, more rounded proportions that minimize heat loss. Neanderthals were not stocky by accident. They were stocky by selection, built by thousands of generations of survival in glacial Europe. Their bones were thick-walled and dense. Their muscles, judging by the attachments and prominences on those bones, were powerful, and their joint surfaces were large, suggesting bodies that did tremendous physical work on a regular basis. But here is something easy to miss if you approach Neanderthals only through the lens of a single famous skull in a museum display case. They were not a single uniform type. They varied. Neanderthals living in southern Iberia during a relatively warm interglacial period would have inhabited a very different world from those living in Central Asia during a glacial maximum. The populations were separated by distance, by geographic barriers, by the slow movement of genes across a vast and often fragmented landscape. Some researchers have identified subtle differences in skull shape and body proportions between Western European Neanderthals and those from the Levant or Central Asia, differences that may reflect local adaptation, genetic drift, or simply the natural variation you expect across any wide-ranging species. The Neanderthals from Shanidar Cave in northern Iraq, from Krapina in Croatia, from La Chapelle-aux-Saints in France, from Vindija, from Kibara in Israel, do not all look identical. They share the core suite of features that define the lineage, but they also carry their own regional character, their own subtle individuality. This matters because it means that when Neanderthals disappeared, they did not disappear as a single homogeneous block. Different populations in different places, with different histories and different neighbours, would have faced different circumstances. The ending, if we can call it that, was almost certainly not uniform. How do scientists identify a Neanderthal in the first place? The answer is layered. Anatomy comes first. The physical features described above, taken together, form a reliable diagnostic suite. No single feature is uniquely Neanderthal. The large nasal passages might appear in other populations. The brow ridge shows up in various archaic humans, but the combination of traits appearing together in the same individual, in the same stratigraphic context, is distinctive. Physical anthropologists have spent well over a century refining the criteria, and while debates continue about edge cases and fragmentary specimens, the core of the Neanderthal sample is identified with reasonable confidence. Then there is the archaeological context. Neanderthal remains are typically found alongside a particular toolkit called the Mousterian, a Middle Paleolithic technology characterized by carefully prepared stone cores from which specific flake shapes were struck, a technique called l'évaluer that required planning and skill and produced remarkably consistent results. The Mousterian is not exclusively Neanderthal, which is one of the reasons archaeology alone can't always determine who made what. But in European and Western Asian contexts, the association between this technology and Neanderthal remains is strong enough to be informative. You find the bones with the tools in the caves and rock shelters and open-air sites that Neanderthals return to again and again over generations. And then, in the last 2 decades, ancient DNA has added a dimension that nothing else could. The sequencing of Neanderthal genomes, first partially accomplished in 2010 and refined considerably since, has allowed researchers to compare their genetic material directly with that of modern humans and with other archaic populations like the Denisovans. This has confirmed the distinctness of the Neanderthal lineage, while also revealing the interwoven history, the interbreeding events, the shared stretches of genetic code that sit in the genomes of people alive today. It has even allowed researchers to identify individual Neanderthals with some specificity, to trace family relationships across a single site, to learn something about population structure and migration. A fragment of bone from a Siberian cave revealed an individual whose mother was Neanderthal and whose father was Denisovan. The ancient world was smaller and more connected and stranger than it once seemed. What all of this evidence builds toward is a picture of a lineage that was genuinely distinct, genuinely widespread and genuinely variable. Not a monolith, but a scattered, diversified, deeply adapted set of populations living across an enormous arc of the old world. They were not simply ancient versions of us, nor were they so alien that we can't recognize ourselves in some of what they did and endured. They occupy an interesting middle place, close enough to be recognizable, different enough to be genuinely other, and that combination, familiar and foreign at once, is part of what makes them so compelling to sit with at the end of a long day, when the world is quiet and the mind is ready to wander somewhere far from the ordinary. Because in thinking about who the Neanderthals were, we're also thinking about what it means to be human at all, where the edges of that word are, and how porous those edges have always been. The world the Neanderthals inhabit was not the world we know. This is easy to say and surprisingly hard to fully absorb, because when we picture Europe or the Middle East or Central Asia, we tend to picture something roughly like the present, with its forests and fields and coastlines in their familiar places. But the Pleistocene was a different arrangement entirely, and sitting with that difference for a moment helps explain a great deal about how Neanderthals lived, and eventually what they faced in their final millennia. During the period when Neanderthals were at their most widespread, and particularly during the last stretch of their existence, the planet was cycling through glacial and interglacial phases in a rhythm that was relentless and indifferent to anything living within it. At glacial maxima, ice sheets pressed down from the north and from mountain ranges across Central Europe, locking up enormous quantities of water and lowering sea levels by 100 metres or more. Coastlines that are now submerged were dry land, forests contracted or vanished, and across much of the territory that Neanderthals called home, the dominant landscape was something researchers call steppe tundra. Vast, cold, windswept grasslands stretching from Western Europe far into Asia, supporting herds of woolly mammoth, woolly rhinoceros, cave lion, bison, reindeer, horse and ibex. It was a productive landscape in its way, rich in large prey animals, but it was also demanding, cold and dry, with extreme seasonal variation in temperature and available resources. Then conditions would shift. Warmer interglacial periods brought forest back into Europe, altered the mix of available animals, changed which plants fruited when and where, and rearranged the migration corridors that both prey animals and the humans hunting them depended on. The transitions between these broad phases were not always gradual. Some of them were abrupt in geological terms, unfolding over centuries rather than millennia, which means that within a single human lifetime, the world could become measurably, materially different. We know this not from inference alone, but from physical records laid down in the earth over tens of thousands of years. Ice cores drilled from Greenland and Antarctica preserve annual layers of compressed snow, and within those layers are trapped air bubbles, dust particles, and chemical signatures that act as a direct read of past atmospheric conditions. The ratio of oxygen isotopes in a given layer tells researchers whether that year's precipitation fell during a warmer or colder period. Pulling these records together, scientists have identified a series of rapid climate oscillations during the late Pleistocene called Dansgaard-Oeschger events, episodes of abrupt warming followed by gradual cooling that punctuated the overall glacial trend. Some of these transitions happened fast enough to matter to individual populations trying to track shifting resources across a changing landscape. Pollen records offer another window. Ancient pollen, preserved in lake sediments and cave deposits, tells researchers what kinds of plants were growing in a given region at a given time. A shift from oak and elm pollen to pine and then to open steppe species represents a real change in the plant community, which cascades into changes in the insects, the herbivores, the predators, and the humans embedded in that food web. Cave deposits add yet another layer. The sediments that accumulate on cave floors over thousands of years preserve evidence of temperature and moisture through the types of minerals that form under different conditions, through the bones of small animals like voles and lemmings, whose preferred habitats tell us something about the climate outside, through the charcoal of ancient fires, and the pollen brought in on wind or fur or clothing. Together, these proxy records build a picture of a world in motion, not chaotic, not featureless, but genuinely and repeatedly disrupted at intervals that would have registered as real and pressing within the lives of the small human populations navigating them. For Neanderthals, climate variability was not an abstract backdrop. It was the operating environment. When a warming event shifted the tree line northward and replaced open steppe with denser forest, the herds of large mammals that Neanderthal groups depended on would have moved. Their migration routes would have changed. Their seasonal concentrations would have shifted, and the hunters who knew those routes would have had to adapt or follow. When a cooling event contracted the range of certain plant foods, or buried a familiar valley under permafrost, the ripple effects would have reached into every aspect of daily survival: where to shelter, what to eat, how far to travel, where other groups of people might be. Mobility was likely a central response to this variability. Archaeological evidence suggests that Neanderthals were not simply cave dwellers waiting for food to appear. They moved across landscapes, sometimes over considerable distances, tracking resources through seasonal rounds that might have taken them from lowland valleys in winter to higher elevations in summer, or along river corridors that connected different ecological zones. The same types of stone, sometimes transported dozens of kilometers from their geological source, appear at different sites, which gives researchers a rough sense of the distances these groups were willing to travel and the territories they considered knowable. But mobility is not free. It carries its own risks. Moving through unfamiliar terrain, crossing territories held by other groups, navigating a changed landscape without the accumulated local knowledge that makes foraging efficient, all of this represents a genuine cost. Climate swings that forced groups to move more or farther or into less familiar ground would have increased those costs precisely when the returns from foraging were already under pressure. The combination of reduced food availability and increased energetic expenditure is not a comfortable one for any small, slow-reproducing population. This is why climate stress has become one of the recurring explanations offered for Neanderthal decline. The logic is plausible, and the evidence for climate disruption during the relevant period is real. There were significant cold events during the time frame when Neanderthal populations appear to have been contracting, and some researchers have drawn direct lines between specific climate downturns visible in proxy records and apparent gaps or reductions in the Neanderthal archaeological record. The reasoning is not unreasonable, and yet, Neanderthals had survived ice ages before. Over the several 100,000 years of their existence as a lineage, they had lived through glacial maxima and warming periods and abrupt oscillations more than once. If climate variability was sufficient on its own to drive them to extinction, it is not immediately clear why it would have done so during this particular window rather than an earlier one. The late Pleistocene climate was not categorically harsher than what came before in every respect, though it was certainly disruptive. Something about the circumstances of those final millennia was different, and climate alone may not capture what that difference was. What climate stress does do, plausibly and importantly, is set the stage. It thins populations, compresses ranges, fragments groups, reduces resilience, and creates conditions under which other pressures that a healthy and widespread population might absorb, become potentially decisive. Climate may have been the background against which the final chapters of Neanderthal history were written, even if it was not the author of the ending. That is a distinction worth holding lightly as the story continues, because the world the Neanderthals were living in when everything began to change was already a demanding one. Cold steppes and shifting seasons, steppe horizons stretching beyond memory, the breath of glaciers on the back of every mountain range. Whatever happened next happened in that world, in those conditions, to those people, and they were, before they were anything else, survivors of a long and difficult history that we are only beginning, slowly, to read. If we zoom in from that wide, shifting landscape to a single group of Neanderthals moving through it, the scale of the story changes. The ice sheets, the pollen records, the Dansgaard-Oeschger events fade into the background, and what comes into focus instead is a handful of people waking up together in the cold light of a Pleistocene morning. The best estimates we have suggest that Neanderthals usually lived in small bands, not thousands, not hundreds, but perhaps a few dozen individuals at most, and often fewer than that. Some researchers think a typical residential group might have been on the order of 10 to 20 people, a couple of related families, older individuals, children of different ages, maybe a few more distant kin or in-laws. These numbers are not written anywhere in the ground. They are inferred from the size of the living spaces, from how many hearths are in use at once, from the way butchery areas and sleeping areas repeat over time in the same parts of a cave or rock shelter. Small populations mean certain things almost automatically. They mean that each person matters a great deal. If a skilled hunter is injured, if a nursing mother falls sick, if an elder with knowledge of local water sources dies, that loss is not buffered by a surplus of others. They mean that social ties outside the immediate band, connections to neighbouring groups, isolation or intermarriage or occasional visiting, can become crucial over the long term to avoid inbreeding and to share information. There are hints of such wider networks in the archaeological record. Stone brought in from distant outcrops, shells far from the sea, patterns suggesting that groups were not completely cut off from one another, even if they lived far apart on a sparse landscape. Within a band, though, daily life was probably intimate and repetitive in ways that modern people sometimes find hard to imagine. The same faces, the same voices, the same routines, day after day, season after season, with very little privacy and almost no anonymity. Decisions, where to camp, when to move, which valley to follow this year, would have been negotiated within this small circle, not by distant authorities, but in the murmured conversations around shared fires. Food would have structured much of this existence. Neanderthals are often pictured as big game specialists, and there is good reason for that. Many sites are dominated by the bones of large animals, bison, horse, reindeer, sometimes mammoth or rhinoceros, bearing cut marks and breakage patterns that show deliberate butchery and the extraction of marrow. Stable isotope studies of Neanderthal bones themselves, where preserved collagen is analysed, suggest a diet very high in animal protein. comparable in some cases to top carnivores like wolves. But that is not the whole picture. In some regions and periods, the remains of smaller animals appear alongside those of large herbivores, rabbits, birds, fish, turtles. Their bones show signs of having been processed and cooked, indicating that Neanderthals were not indifferent to these resources when they were available and worthwhile. Plant remains are rarer because plants preserve poorly, but even here traces exist. Microscopic wear on Neanderthal teeth and the tiny plant particles trapped in ancient dental calculus, the hardened plaque on fossil teeth, reveal that they chewed a variety of plant foods, including seeds, nuts, and possibly starchy underground parts like roots and tubers. Taken together, these lines of evidence point to a flexible, seasonally tuned diet. In winter, when plants were scarce and large migrating animals were concentrated in predictable places, the band might have focused on big game hunting, investing time and risk in cooperative drives or ambushes that, if successful, could feed everyone for days. In warmer seasons or in more forested regions, smaller game and plant foods may have filled in the gaps, gathered or trapped, or dug up during shorter forays from camp. The exact balance likely shifted from place to place and century to century, which is why researchers are cautious about any single, simple description of the Neanderthal diet. Where these small bands slept and sheltered themselves also varied with local conditions. Caves and rock shelters loom large in our imagination partly because they preserve evidence well. A stable overhang protects hearths, bones, and stone tools from the worst of the weather and later erosion, so those are the places we are most likely to excavate. But the same stone tools and animal remains also turn up in open-air sites, on river terraces, in former lake basins, on elevated ridges. In these exposed settings, Neanderthals probably built more ephemeral shelters, windbreaks of branches and hides, simple structures using mammoth bones or wooden posts. The kind of constructions that rarely leave obvious traces after tens of thousands of years. Fire seems to have been a constant companion, as far as we can tell. Hearths appear again and again in Neanderthal sites. Shallow basins of ash and charcoal, reddened earth, fire-cracked stone. In some caves, these hearths recur in the same spots over long stretches of time, suggesting a habitual way of organizing space. Fire here, sleeping areas there, butchery and tool-making a little farther away. Fire would have warmed cold nights, dried skins and clothing, extended waking hours into the dark, and made certain foods more digestible. It also has a less visible role. It helps save energy. Living in cold environments with large muscular bodies and active hunting lifestyles, Neanderthals likely had high energy demands. Every decision about where to camp, how far to travel, and what to hunt or gather would have been filtered, consciously or not, through a logic of calories. Energy in versus energy out. Walking 10 extra kilometers for slightly better hunting might or might not be worth it. Carrying a heavy carcass back to a sheltered spot with a reliable fire meant that more of that energy could actually be used by the group. A day's routine, who stayed near camp, who ranged out, who processed food, who watched children, would have been shaped by this constant negotiation with the environment. One of the most striking windows into the social world behind these routines comes from injuries. Neanderthal skeletons often show healed fractures, including serious ones. Broken arms, damaged legs, spinal injuries, severe arthritis, evidence of chronic pain. Some individuals live for years or even decades after injuries that would have made independent foraging extremely difficult, if not impossible. This implies that others carried them, shared food with them, made room for them by the fire, tended to their wounds as best they could. There are cases of older Neanderthals with worn teeth and joint damage consistent with a long life of hard use, who nonetheless survived into ages that, in such demanding conditions, would have required support. One famous skeleton from Shanidar Cave in Iraq shows multiple serious injuries, including a withered arm and damaged eye socket, yet this person lived on for many years. The exact details of care, how much, how often, in what spirit, are beyond our reach, but the fact of survival itself is a form of evidence. It suggests a level of social support and cooperation that goes beyond a purely opportunistic association of hungry individuals. At the same time, we have to remember how much is missing from this picture. Bones and stones and ash do not tell us what jokes were told, what stories were passed down on long winter nights, what disputes flared and cooled, what private griefs or quiet joys moved through those small bands. We infer group size from hearths, diets from isotopes, care from healed fractures. We compare these patterns to those seen in recent hunter-gatherer societies, while knowing that the parallels are imperfect. There is a real risk of smoothing over the strangeness of another kind of human life with assumptions drawn from our own. So when we imagine daily life in these small Neanderthal bands, it is worth holding two thoughts at once. On one hand, they were embedded in the same basic constraints that shape all human foragers: the need for food, shelter, warmth, social bonds, and the successful raising of children in a demanding world. On the other hand, they were not simply us in different clothing. Their bodies, their histories, their environments, and perhaps their ways of thinking and relating were their own. Between what we can see in the ground and what we can only guess at, a quiet, tentative portrait emerges. Small groups, moving across a restless landscape, bound together by necessity and familiarity, sharing firelight and food, carrying their injured and their old, making a living at the edge of the Ice Age in ways that were at once deeply practical and, in their own terms, surely meaningful. If we stay with that small band for a while longer and look not just at what they ate or where they slept, but at what they held in their hands, another dimension of their lives comes into view. Scattered around the hearth, in ash and trampled earth, are the hard remains of a technology that lasted for hundreds of thousands of years: stone tools. These are often the most visible traces Neanderthals left behind, and they are not random. They belong to traditions that archaeologists call Middle Paleolithic, with a particular style in Western Eurasia that is often associated with Neanderthals, the Mousterian. At first glance, these tools can seem unremarkable. There are no delicate blades of obsidian, no barbed harpoons, no bone needles with drilled eyes from the later Upper Paleolithic. Instead, we find thick flakes and points, scraping tools with steep, retouched edges, robust cutting implements made from flint, chert, quartzite, whatever suitable rock was at hand. But the apparent simplicity is deceptive. Behind each of these pieces lies a chain of decisions, a mental template for how stone should break, and a practiced control over force and angle. One of the best-known techniques linked to Neanderthals is called the Levallois method. In this system, a napper carefully prepares a stone core, shaping its surface so that, with one well-aimed blow, a flake of a desired size and shape will detach. This is not something one casually discovers in a spare afternoon. It requires an understanding of three-dimensional geometry and the ability to plan several steps ahead, preparing the platform, shaping the convexities, striking in just the right place. Many modern people, even with instruction, struggle to reproduce it. When such prepared core technologies appear in different regions in consistent ways, they tell us something about more than just one clever individual. They hint at shared learning traditions, at knowledge passed down from elders to learners, at apprentices watching and practicing, making mistakes and slowly improving. Variants of these Middle Paleolithic toolkits spread over vast areas, sometimes with regional flavours, slightly different ways of shaping scrapers here, different preferences for points there. These patterns are one way archaeologists trace what might have been learning networks, groups in contact, exchanging mates and stories and very likely techniques. Changes in stone tools over time also speak quietly about other shifts that we cannot see directly. When a new form of point or a new way of preparing a core appears in a region, it can mean that people began to move differently across the landscape, or that they focused on different resources. A more portable toolkit might signal longer foraging ranges, or a need to carry useful tools between scarce raw material sources. A greater emphasis on tools suited to hide scraping might reflect changing climates and the increased importance of well-made clothing and shelters. These inferences are always cautious, always debated. Stone is both generous and frustrating. It preserves magnificently, but it records only a thin slice of daily life. Still, over tens of thousands of years, the accumulation of these small shifts creates a timeline of cultural change, even when everything else has vanished. And stone was not all there was. Increasingly, we find hints of more complex technologies that rarely survive. At some Neanderthal sites, residues on stone points and flakes contain traces of plant resins, bitumen, or other sticky substances that seem to have been used as adhesives. This suggests that stone tools were not simply held in the hand, but were sometimes hafted, fixed to wooden shafts or handles with carefully prepared glues and bindings. Making a reliable hafted spear or knife is not trivial. It requires a sequence of steps: selecting appropriate wood, shaping it, preparing the stone insert, gathering resin or pitch, possibly heating and mixing it with other materials like ochre or fibers to improve its properties, then assembling everything so that the finished tool can withstand powerful impacts. Experiments with similar adhesives show that they demand close control of temperature and timing. Too cold, and the pitch stays crumbly. Too hot, and it burns and loses its stickiness. This kind of know-how is a form of embodied knowledge, stored not in bones or genes, but in habits, practices, and shared techniques. It suggests teaching, demonstration, and correction over extended periods. Someone watches as a more experienced hand holds a piece of resin over a fire just long enough, then kneads it together with powdered mineral. Someone else learns by trying to throw a spear and seeing the head snap off, then being shown how to lash it more securely. The same is true for other materials that rarely leave clear traces. Wooden digging sticks, simple spears, perhaps woven slings or containers made from plant fibers or animal skins. All of these would have been part of Neanderthal life, yet only in rare, exceptional conditions do pieces of wood or cord survive long enough for us to find them. In a few sites, short wooden spears and shaped sticks associated with Neanderthals hint that their technological world was richer than stone alone suggests. Beyond the strictly practical tools, there are tantalizing signs of behaviors that some researchers would call symbolic, and others would prefer to describe more cautiously. Pieces of mineral pigment, especially iron oxides, ochres, turn up at a number of Neanderthal sites. In some cases, the pigments show grinding or scraping marks, suggesting deliberate processing. What were they for? They could have been used to tan hides, as a functional component in adhesives, or as a simple colouring agent for objects or bodies, or all of these, at different times. There are also perforated or modified shells and possible pendants from contexts associated with late Neanderthals, particularly in parts of Iberia and Italy. Some of these shells show traces of pigment, as if they had been coloured and perhaps strung together. Whether this represents personal ornamentation in the way we understand it, jewellery conveying identity, status, or group belonging is still discussed. Contamination from later occupations, the mixing of layers, and the small number of such finds mean that interpretations have to be careful. Burials are another area where the line between practical behaviour and symbolic meaning is hard to draw. At sites like La Chapelle-aux-Saints in France or Shanidar in Iraq, Neanderthal skeletons appear in positions that some archaeologists interpret as deliberate burials, bodies placed in dug pits, sometimes with the head resting on a stone, limbs arranged rather than scattered. Others argue that natural processes can mimic such arrangements, or that later disturbances make it unsafe to reconstruct original intent. Earlier suggestions of flowers placed with the dead at Shanidar, for example, have been questioned by more recent analyses. What seems reasonable to say is that Neanderthals sometimes did something more than simply abandon their dead where they fell. Whether that more always carried a symbolic load similar to modern funerary practices, or whether it was driven by hygienic concerns, predator avoidance, or a mix of motives remains uncertain. But even the act of moving and placing a body implies emotional and social responses to death that go beyond indifference. Taken together, pigments, possible ornaments, selected objects placed with bodies, the evidence hints at moments when the Neanderthal world included signs, markers, or practices that were not strictly utilitarian, or at least not only utilitarian. How far this extended into storytelling, ritual, or shared myth is an open question, and likely always will be. The silence of the archaeological record here is deep. Yet across the span of Neanderthal history, there are indications that the tempo of cultural change was not constant. For long stretches, tool traditions appear relatively stable, with slow, regionally varied adjustments rather than dramatic revolutions. Then, toward the later phases of their existence, in some regions we start to see what look like accelerations, more elaborate hafting technologies, a broader range of tool forms, perhaps more frequent use of pigments and possible ornaments, and, at certain sites, technologies that resemble those of early Homo sapiens nearby. Some researchers see in this a sign of increasing innovation, or of contact and cultural exchange between Neanderthals and incoming modern humans. Others emphasize that our view is patchy, that a few well-preserved late sites may be biasing our perspective. Whatever the exact cause, the impression is that Neanderthal culture near its end was not static. It was shifting, adapting, experimenting, perhaps under new pressures or within new networks of interaction. In this interplay of stone, wood, adhesive, colour and choice, The meaning of culture for Neanderthals comes into focus not as an abstract concept, but as a lived reality, a shared repertoire of ways to do things, transmitted across generations, slowly modified over time. As their story moves toward its final chapters, this cultural fabric will become even more important, because it is through these fragile traces of skill and style that we can begin to glimpse how Neanderthals responded when other humans very much like us, appeared on their horizon. If we follow those traces of skill and style a little further, another question rises quietly in the background, one we can't answer by holding a stone or measuring a bone. What was it like to think as a Neanderthal? What did the world feel like from inside one of those heavy brows and broad faces? For a long time, people talked about Neanderthals as if the answer was simple. They were cast as slow, unimaginative, driven by instinct rather than thought. In older museum displays and popular books, they grunt rather than speak, copy rather than invent, lurk at the margins while real humans stride past them into the future. Those images say more about us than about them. The archaeological record that we have already touched on, planned core preparation, complex hafting, flexible hunting strategies, occasional pigments and possible ornaments, does not sit comfortably with the idea of dull, unreflective beings. To prepare a Levallois core, or to cook resins at the right temperature, is to hold a plan in mind, to imagine an outcome before it exists, to adjust behaviour when things do not go as expected. These are not the actions of creatures bound only to the present moment. Still, turning tools and bones into thoughts and inner lives is not straightforward. We can see what Neanderthals did. We can rarely see what they meant by it. So we begin, cautiously, with the parts of them that have fossilized. In the skulls of Neanderthals there is a bony hollow at the base where the spinal cord enters, and beside it, the impressions of structures that in us support speech. The basic cranium, the spaces for the tongue and larynx, the arches that frame the throat. These do not form a perfect blueprint for a voice, but when anthropologists compare Neanderthal skull bases to those of earlier humans and to our own, they find broad similarities. The shape of the hyoid bone, a small horseshoe-shaped bone in the throat of one Neanderthal from Israel, also closely resembles that of modern humans. In us, this bone helps anchor the muscles of the tongue and larynx, crucial for articulate speech. Genetics adds another piece. In the genomes recovered from Neanderthal bones, there are versions of genes that in modern humans are associated with aspects of speech and language, including a well-known one called FOXP2. The Neanderthal versions of these genes look much like ours, more so than those of earlier branching lineages. It is tempting to string these clues together and declare that Neanderthals must have spoken exactly as we do, with the same range of sounds and the same kind of language. But each step of that argument carries uncertainties. The position of the larynx, the fine control of breath and tongue, the wiring of the brain's language areas, these are not preserved directly. Even in living people, genes associated with language are part of a wide and complex network. They do not map neatly onto vocabulary size or grammar. What the anatomical and genetic evidence can reasonably suggest is that Neanderthals had the physical and neurological potential for fairly complex vocal communication, not just a handful of calls or crude noises. How that potential was realized, in what kinds of languages, with what levels of complexity and what sorts of metaphors or stories, lies beyond our reach. We can, however, look at their behavior for signs of minds that could plan, remember, and teach. The persistence of specific tool traditions over vast areas and long spans of time hints at structured learning. Children do not emerge from the womb knowing how to prepare a core or mix resin with the right proportion of ochre. They need demonstration, correction, repetition. They need others who are willing to slow their own work to show them, who care if the next generation can do what they can do. This social learning is a kind of invisible architecture. It connects individuals across time, allowing knowledge to accumulate. In our own species, such networks can grow dense and wide, with ideas and techniques spreading far beyond their place of origin. For Neanderthals, the pattern seems to have been different. Their groups were likely small, scattered across challenging environments, with bands occasionally meeting, exchanging mates, gossip and skills, and then separating again. In such a world, knowledge behaves differently. It can pool within a region, and then evaporate if a few key individuals die, or if a band is cut off from its neighbours by shifting ice, drying rivers, or the disappearance of a migration route. a refined method for producing sturdy spear points, learned by a handful of hunters in one valley, might never spread far enough to become common. A useful trick for preserving meat or for treating a painful wound might vanish when the last person who knows it is lost to an accident or an infection. This is one way to think about Neanderthal minds without reducing them to a simple ranking against ours. It may not be that they lacked the capacity to innovate, but that their social networks were thinner, more fragile. In that situation, culture is less like a rising tide and more like a chain of small fires, some of which go out before they can light the next one. Stress complicates this picture further. When climates swung rapidly, when key animal herds shifted their ranges, when plant communities changed, groups may have found themselves in unfamiliar conditions. Under pressure, when hunts fail more often, when winter comes early, when illness spreads, people tend to focus on immediate needs. Time spent experimenting with new tools or teaching elaborate techniques to the young might shrink. Conservatism, sticking with the known, can be a rational response when risks are high and margins are thin. Isolation magnifies this effect. A band trapped between advancing glaciers and a swelling river, or hemmed in by competitors, might find its options narrowing. Fewer safe pathways through the landscape mean fewer chances to meet other groups, fewer occasions to learn a slightly different way of doing things. Innovations that do arise might remain local quirks rather than spreading, and sometimes they may not arise at all simply because the right combination of minds and moments never meet. None of this requires that Neanderthals had simpler thoughts or shallower feelings. It may be that their inner worlds were as rich in memory, attachment, and imagination as our own, but that the scaffolding for widespread, rapidly changing culture, large population sizes, dense webs of contact, cumulative transmission over many generations was less robust, and this is where the limits of our understanding press in. We can map nerve canals and fossil skulls, model lungs and throats, sequence ancient DNA, and catalogue every flake of stone from a site. We can build careful arguments about planning depth and teaching, about social learning and demographic fragility. What we cannot do is listen to a Neanderthal tell a story, complain about the weather, or sing a child to sleep. We do not know what they dreamed about by the fire, what fears visited them in the dark, what names they had for constellations, animals, or each other. We do not know how they thought about death, or what they believed lay beyond the horizon or beneath the ground. The best we can do is trace the outer contours of their minds through the marks those minds left on the world. As we move onward, toward the last landscapes they occupied, and the arrival of other humans on their doorstep, this silence about their inner lives will remain. It will shape how we think about their disappearance, and how carefully we must separate what the evidence supports from the stories we're tempted to tell. When we talk about the last Neanderthals, it is easy to picture a cliff edge in time. One moment they are there, the next they're gone. But the archaeological record does not unfold like a cleanly edited story. It comes to us in fragments, a hearth here, a cluster of bones there, a few stone tools pressed into a layer of sediment. From these scattered traces, researchers try to sketch not just the final chapter, but the shape of the landscape in which it was written. One idea that has slowly emerged is that of refugia, places of refuge. As climates shifted at the end of the Ice Age cycles Neanderthals lived through, their favoured habitats did not simply vanish overnight. They shrank, broke apart, and retreated into pockets where conditions remained bearable. In these pockets, it seems, Neanderthals may have persisted longer than in the surrounding regions, holding on in familiar valleys and coastlines while other areas emptied out. On a map of Eurasia, the classic Neanderthal range spreads from the Atlantic coasts of Iberia, across much of Europe, into Western Asia and parts of the Near East. By the later stages of their history, that broad expanse appears to thin. Fewer sites, more distance between them, more absences where once there were signs of regular occupation. Within this patchier pattern, a few regions have attracted particular attention as possible late refugees. Southern Iberia, the southern parts of what is now Spain and Portugal, has long been one of the main candidates. Sites like Gorham's Cave on the Rock of Gibraltar, perched above the Mediterranean, and nearby caves in the region have produced Neanderthal tools, and in some cases what appear to be hearths and butchered animal bones, in layers that were once argued to be surprisingly young. For a time, some studies suggested that Neanderthals here might have survived several thousand years longer than their counterparts farther north, perhaps living on the edges of rich coastal ecosystems while other Neanderthal populations had already disappeared. Further east, parts of the Balkans, Greece and the Caucasus have also entered discussions of late survival. In some caves there, stone tool traditions associated with Neanderthals seem to stretch later in time than in Central or Northern Europe. In Western Asia, particularly in areas that are now politically difficult to access or poorly explored archaeologically, there are hints that the story of late Neanderthals might not yet be fully told. Even within Central and Western Europe, which are comparatively well studied, there are suggestions of uneven endings. Some valleys and plateaus show a relatively abrupt disappearance of Neanderthal tools and bones. Others, especially in rugged or sheltered landscapes, show what might be more drawn-out intermittent use. It is as if their occupation of Europe turned from a solid, continuous presence into scattered islands, each with its own local history. Yet every piece of this late survival map is tangled up with the way we date the remains. The bones and charcoal and sediments do not come with labels. They must be placed in time using methods that have strengths and limits, and those methods have been refined dramatically over the last few decades. As they change, so do the timelines we draw. For this period, the main tool is radiocarbon dating, which measures the decay of a radioactive form of carbon in once living material. In ideal conditions, radiocarbon can give reasonably precise ages for things up to around 50,000 years old. The last Neanderthals, and the first members of our own species in Eurasia, cluster uneasily near this horizon of method. Dates near the limit become harder to interpret. Small amounts of contamination by younger carbon can make something appear significantly more recent than it really is. Many of the most strikingly young dates for Neanderthal sites came from early generations of radiocarbon work, when techniques for cleaning samples were less sophisticated, and when cave deposits were less carefully disentangled layer by layer. Later studies have often gone back to the same sites, resampling bones and charcoal, applying more rigorous pre-treatment to remove contaminants, and using improved instruments. In quite a few cases, those redated remains have turned out to be older than first thought. This has been especially true in some of the supposed refugia. Caves in southern Iberia, once heralded as the last Neanderthal strongholds tens of thousands of years after their disappearance elsewhere, have seen their timelines shift backward as new dates are produced. In some cases, samples that were thought to be from Neanderthal layers turn out, on closer inspection, to come from sediments disturbed by burrowing animals, landslides, or human excavation. In others, layers once assigned to Neanderthals, based on the types of tools present, have been reinterpreted as mixtures of Neanderthal and early Homo sapiens artifacts. To make sense of this complexity, researchers increasingly use Bayesian modelling. Instead of treating each date as a standalone number, these models combine radiocarbon ages with information about the archaeological context, which layers lie above or below which, how tools change through time, how sites in a region relate to one another. The result is a set of probability distributions rather than single, sharp dates, a range of likely intervals during which a site was occupied, and during which Neanderthals were probably present in a given area. When those modelled timelines are compared across regions, a broad pattern emerges. The Neanderthal range appears to contract. Northern and eastern areas see the disappearance of their typical tools earlier. Central Europe follows, southern refuges, Mediterranean coasts, peninsulas, sheltered mountain valleys, hold on somewhat longer, though not as dramatically longer as once claimed. The occupation becomes more intermittent. Gaps appear in sequences of layers, suggesting that some caves used to be visited regularly and then only occasionally, or not at all. This patchiness can mean different things. In some places it might reflect genuinely smaller populations, bands that no longer have the numbers to use every part of the landscape every year. In others, it may be a sampling issue, caves that by chance preserved only a few brief visits. Still, when many sites are considered together, the overall impression is of a species whose footprint on the land is shrinking. It is important to remember that when archaeologists talk about the last Neanderthals in southern Spain, or the Caucasus or any other region, they are really saying something more modest. These are the youngest Neanderthal remains we have found so far that we can date with some confidence. The global record is incomplete. Vast areas that once lay within Neanderthal range have not been systematically explored, and many sites that do exist have been destroyed by erosion, development, or simple chance long before anyone could study them. The final Neanderthal individual may have died in a valley that has never been excavated, in a cave that collapsed and sealed itself, or in an open landscape where wind and water scattered every trace. Our maps of refugia, our curves of last appearance, are built from what happens to have survived and what we have happened to find. What they do suggest, quietly but persistently, is that the end was not a single night, not a cliff edge in time, but a long dusk. Ranges contracting, groups thinning out, some regions emptying early, others hanging on in isolated pockets. Into this changing mosaic of Neanderthal landscapes, another human species was moving, often following the same valleys, rivers and coasts. To understand what happened when their paths crossed, we have to carry this image with us. Not a world where Neanderthals vanish all at once, but one where, place by place, their voices fall silent. Into this thinning Neanderthal world, another kind of human was moving. By the time Neanderthal ranges were shrinking in Europe, our own species, Homo sapiens, had already begun its long journey out of Africa. The story of how and when is not written in a single line of footprints, but in scattered traces. A jawbone in a cave in Israel, a few teeth in Greece, a tool chipped from stone on a windswept plain. The broad outline, as it is usually understood today, goes something like this. Our species evolved in Africa, and had been living there for a long time before any of its members established a lasting presence elsewhere. There are hints of earlier, perhaps brief expansions into the Levant, places like Skul and Kafse in what is now Israel, with Homo sapiens bones that may reach back beyond 100,000 years. These early forays seem not to have led to permanent settlement in Eurasia. They appear and then vanish from the record, like a tentative step forward and a retreat. The expansion that eventually did spread Homo sapiens widely across Eurasia seems to gather momentum somewhere around 60,000 to 50,000 years ago, perhaps a little earlier in some regions, perhaps later in others. From northeastern Africa and the eastern Mediterranean, groups of our species likely moved along multiple routes, up through the Near East, fanning into Western Asia, skirting coastlines of the Arabian Peninsula, threading through river valleys that are now buried or dry. From these staging grounds, some bands turned north and west into Europe, others moved east across the steppe belts towards Central and Northern Asia, and eventually into regions that would later become China and Siberia. These movements were not a single wave rolling across a map. They were more like many small ripples, uneven in time and space. Some groups may have expanded rapidly into new open territories, others may have paused for generations at bottlenecks, narrow corridors of habitable land before moving on. At every step they were entering environments where other hominin populations had long established histories, including Neanderthals in Europe and Western Asia, and other archaic groups farther east. Archaeologists do not see these migrations directly. Instead, they see changes in what is left behind. One of the main clues is stone tools. Different ways of shaping stone, different choices of raw materials, different combinations of tools in a site can form what researchers call industries, or technocomplexes. These are not ethnic labels, and they are not one-to-one maps to particular species, but they help trace patterns. For much of their history, Neanderthals in Europe are associated with what is called the Mousterian, a way of preparing stone cores and striking off flakes of fairly standardized shapes, then refining those flakes into scrapers, points, and other tools. In some regions, right near the end of Neanderthal presence, there are distinctive local variants such as the Châtelperronian in parts of France and northern Spain, which includes blades and personal ornaments in addition to more classic Neanderthal-style tools. As Homo sapiens appear in the Eurasian record, different industries become more common. In many areas of Europe, the earliest widely accepted traces of our species are linked with what archaeologists call the Aurignacian. These assemblages often include long, slender blades, bone tools, and sometimes ornaments made from teeth, shells, or ivory. Farther east, other early Homo sapiens groups are associated with their own local traditions, some blade-heavy, some more mixed. But the reality on the ground, especially in the key interval when Neanderthals and Homo sapiens overlapped, is complicated. There are transitional industries, tool traditions that show a blend of features or that do not fit neatly into either category. Some scholars argue that these represent Neanderthals experimenting with new techniques, perhaps influenced by contact with our species. Others suggest they may be the earliest traces of Homo sapiens in different regions, adapting their methods to local resources and inherited habits. At some sites, we have tools but no bones at all, and the debate over who made what can remain unresolved. This is where the idea of contact zones becomes important. Instead of imagining a sharp front line, with Neanderthals on one side and Homo sapiens on the other, it may be more accurate to picture wide regions where their ranges overlapped in time and space. In those zones, many different things could have happened. In some valleys, the two species might barely have noticed each other for long stretches of time, using different parts of the landscape in different seasons, missing one another by chance more often than not. In other places, small bands could have watched smoke from unfamiliar hearths rising on a distant ridge, or noticed new footprints near a water source they thought of as their own. Contact might have taken the form of avoidance, groups steering around each other's territories, following rumours of danger, or simply keeping to old familiar routes. It might have involved cautious observation, then limited exchange. Objects passed from hand to hand, a piece of high-quality flint from far away, a shell from a distant coast, a fragment of bone shaped in an unfamiliar style. There is even the possibility, suggested by some artifacts and by genetic evidence, of deeper interactions, sharing of knowledge, imitation of techniques, and interbreeding. Competition is also a plausible part of this picture, though it need not mean constant open conflict. Two closely related species, hunting many of the same animals and gathering many of the same plants, living through the same cold winters and unstable climates, would inevitably put pressure on one another's resources. Sometimes that pressure might have been indirect, one species reaching a good valley first, leaving less game for the other. Sometimes, perhaps, it may have been more direct, disputes over access to a rich cave or a narrow river crossing. Crucially, these contact zones were not uniform across Eurasia, and they did not all exist at the same time. In some parts of Western Asia, Neanderthals and Homo sapiens may have overlapped for longer periods, with back-and-forth movements as climates shifted. In parts of Europe, the arrival of Homo sapiens appears relatively early. In others, Neanderthals seem to persist without clear evidence of our species for thousands of years, until suddenly the archaeological record shifts. When researchers compare modelled dates for Neanderthal occupations with the earliest sites attributed to Homo sapiens, the resulting timelines show a patchwork of overlap. In a few regions, the last Neanderthal traces and the first Homo sapiens traces seem almost to touch, with perhaps only centuries or a very few millennia separating them, and maybe some genuine coexistence. In others, there may be gaps where Neanderthals disappear before Homo sapiens become visible, though such gaps may also simply reflect the incompleteness of our record. This mosaic makes it harder to tell a straightforward replacement story, where one species sweeps in and instantly displaces another everywhere it finds it. There were real demographic changes. By around 40,000 years ago, or somewhat later, Neanderthal fossils vanish from the known record, while Homo sapiens sites become increasingly common and widespread. Over the long arc, our species came to occupy territories that had once been Neanderthal domains. Yet what happened in those overlapping centuries likely varied greatly from place to place. In some landscapes, the change might have been rapid, as small Neanderthal groups already reduced in number encountered expanding Homo sapiens bands and gradually lost ground. In others, there may have been prolonged coexistence, with intermarriage, cultural borrowing, and slow intertwined shifts in population size. In still others, Neanderthals may have retreated into marginal refuges, fading away out of direct contact, their last fires burning in quiet isolation. Rather than a single narrative of conquest, the spread of Homo sapiens and the disappearance of Neanderthals seems to have been a complex weave of movements and meetings, of crossings and missings, of shared landscapes differently used. Into that weave we now have to thread another strand, the genetic evidence that shows traces of Neanderthals living on, not only in the caves and sediments they left behind, but inside the bodies of many people alive today. When scientists first managed to sequence Neanderthal DNA, they were not expecting to find it quietly threaded through so many of us. The early hope was simply to read the genome of a vanished population, to compare it with our own, and to see where the branches of the human family tree diverged. But as more data came in, a different pattern emerged. When the genomes of living people from different parts of the world were lined up next to the Neanderthal sequence, a faint but unmistakable echo appeared. For most people whose ancestry lies outside of sub-Saharan Africa, roughly 1 to a few % of their DNA seems to come from Neanderthals. In some individuals it is a little higher, in some a little lower, and the exact numbers have been revised more than once as methods improve. But the overall picture has held. Many living humans carry small stretches of Neanderthal genetic material inside their cells. This does not mean that one or two of your great-grandparents were Neanderthals. The interbreeding events that left this legacy happened tens of thousands of years ago, and the Neanderthal segments in living people have been broken up, shuffled and diluted by countless generations of recombination. What remains today are scattered fragments, short stretches on different chromosomes, that can be recognized because they are more similar to Neanderthal sequences than to those of African populations who did not experience the same contacts. The presence of these fragments tells us, very simply and very powerfully, that Neanderthals and Homo sapiens did not remain completely separate wherever they met. At least in some times and places, they had children together, and some of those children grew up and had descendants of their own. Geneticists use the term introgression for this process. Genes from one population entering the gene pool of another through interbreeding. Introgression can leave behind a patchwork of clues, but it is important to be careful about what those clues can and cannot say. From the amount of Neanderthal DNA in living humans, researchers can roughly estimate how many interbreeding events there might have been, and when they are most likely to have occurred. The strongest signals seem to come from early encounters, perhaps somewhere in Western Asia, as expanding Homo sapiens groups first moved out of Africa and into regions where Neanderthals already lived. There are hints of later contacts as well, including in parts of Europe and possibly in Siberia, though teasing apart these episodes is an ongoing effort. What the genetics cannot yet do with precision is reconstruct the details of those relationships. A percentage of DNA does not tell us who married whom, whether unions were rare and secretive or more socially accepted, whether they involved long-term partnerships or brief encounters. It does not show us how individuals felt about each other, or what stories were told about those meetings around the fire. Nor does the small overall percentage of Neanderthal ancestry in living people mean that only a handful of Neanderthal individuals ever entered our lineage. Population genetics is subtle. A single successful interbreeding event, in a group that later expands widely, can leave a surprisingly broad legacy. Many events, in populations that later dwindle or become isolated, can leave almost no trace at all. So while the genetic evidence confirms that interbreeding happened, it cannot by itself measure how common it was on the ground in any one valley, or what proportion of Neanderthals overall ever contributed genes to our species' future. The numbers we see today are the end result of many filters: chance, survival, migration, and the accidents of which lineages happen to grow. Within the tapestry of our genomes, some Neanderthal-derived variants look as though they may have been helpful to the Homo sapiens groups that carried them. Others appear to have been harmful, at least under some conditions, and have been gradually removed or reduced by natural selection. In several cases, Neanderthal versions of genes involved in the immune system appear more common than would be expected by chance. Some of these genes help recognize pathogens or trigger inflammatory responses. One possibility is that, as Homo sapiens moved into new environments full of unfamiliar microbes, Neanderthal adaptations offered a small advantage. A head start dealing with local diseases, honed over long Neanderthal residence in those regions. There are also Neanderthal-derived variants associated in modern populations with skin and hair traits, pigmentation, thickness, or how the skin responds to sunlight. In Ice Age Eurasia, where light levels were lower and seasons extreme, different skin responses to sunlight and cold may have mattered for vitamin production, frostbite risk, or other subtle aspects of physiology. Some Neanderthal variants in these pathways may have been favoured, others not. On the other hand, some introgressed fragments seem to be linked, in present-day studies, with increased risk for certain conditions, aspects of mood, metabolism, blood clotting, or susceptibility to modern diseases. In many places across the genome, Neanderthal-derived sequences are surprisingly rare or entirely missing, as if natural selection has pruned them away, suggesting that in those regions Neanderthal variants did not mesh well with the rest of the Homo sapiens genetic background. It is tempting to tell a neat story, that Neanderthals passed us useful defences and burdensome weaknesses, shaping our health today. There may be some truth in that, but the details are still being worked out, and modern environments are very different from those in which these genes originally evolved. A variant that once offered an advantage in a cold, pathogen-rich Ice Age forest might interact quite differently with city air, modern diets, and contemporary lifespans. The broader implication, though, is that Neanderthal DNA inside us has been anything but neutral. It has been tested, generation after generation, by survival and reproduction. Some pieces have been kept, some altered, some discarded. In that sense, Neanderthal genes did not just persist, they participated in the continuing evolution of our species. If some Neanderthal DNA flowed into Homo sapiens populations, then the boundary between the two species, at least in a genetic sense, becomes a little less sharp. This opens a quiet but profound possibility, that in some regions Neanderthal groups were not simply pushed aside or extinguished, but gradually absorbed. Imagine a small Neanderthal band living in a valley where Homo sapiens groups are becoming more common. Over time, perhaps a few individuals join neighbouring bands through marriage or adoption, or children of mixed ancestry begin to identify, in whatever social terms existed then, with the expanding group rather than the shrinking one. As generations pass, the distinct Neanderthal band disappears, not because its members have all died without issue, but because their descendants now belong to a different, larger network. This kind of demographic absorption is familiar in more recent history, where smaller populations have fused into larger ones, losing their distinct identity even while their genes persist. The genetic evidence from the late Pleistocene allows a similar scenario for at least some Neanderthal communities, a fading not only by absence, but by blending. Of course, absorption is unlikely to have been the only path. In other times and places, Neanderthal groups may have vanished through isolation, low birth rates, accidents, or competition without much interbreeding at all. The genetic signal we see today is global and averaged. It cannot tell us which specific valleys witnessed merging and which saw separation or quiet decline. It is also important to remember that genetics is only one way of listening to the past. DNA sequences can reveal patterns of ancestry, timing of population splits, and traces of ancient contact. They are extraordinarily powerful tools, especially when combined with fossils and archaeology. But they are not a complete story. They cannot on their own show us the texture of daily interactions, the emotional weight of encounters, the meanings that Neanderthals and Homo sapiens might have given to each other. They do not tell us how groups organized themselves, how they shared or defended resources, how stories and skills flowed between them alongside genes. To understand what happened to the Neanderthals, the genetic afterlife we carry is one important strand, but it sits alongside many others: the chipped stones and butchered bones, the charcoal layers and pollen grains, the dates and climate records that frame where and when different populations lived. Together, these lines of evidence suggest a past where Neanderthals did not simply vanish at a stroke. Some of their genes travelled forward, folded quietly into our species. Their biological legacy continues in subtle ways in skin and immune systems, in metabolisms, and perhaps in other traits not yet fully recognized. Yet a few surviving genetic fragments are not the same as a living people, with their own languages, traditions, and ways of seeing the world. For that, we must look beyond molecules, back out into landscapes, and into the complex web of interactions that shaped the last chapters of Neanderthal history. Chapters in which contact with our species was only one of several forces at work. When we picture two human species sharing a continent, it is easy to slip into a story of battle lines, one side advancing, the other retreating, clashes over hunting grounds, a simple contest with winners and losers. The evidence we actually have points towards something quieter and more complex. By the time Homo sapiens groups began to spread widely across Eurasia, Neanderthals had already been living there for hundreds of thousands of years. They knew the caves, the passes, the seasons of the migrating herds, but the two populations seem to have differed in several subtle ways that matter when we think about competition, even when no one is raising a spear. One difference may have been sheer numbers. Many models suggest that, averaged over large regions, Homo sapiens populations were somewhat larger, and sometimes grew faster. Even if each band was still small, scattered across huge landscapes, a slightly higher birth rate here, a slightly lower death rate there, can add up when viewed over centuries. Another difference may have been in how widely connected groups were. Neanderthal bands certainly moved, and there is evidence of raw materials and tools travelling over respectable distances, but in some regions Homo sapiens seem to have maintained broader social networks, passing ideas and objects across longer chains of contact. In archaeological layers associated with our species, certain styles of tools, ornaments, or pigments appear over large areas, hinting at cultural ties binding distant communities together. A band that belongs to a wide network has more options during hard times. If game is scarce in one valley, individuals might have kin or allies in another farther away who can take them in, exchange food, or share information about where herds have shifted. If your world is stitched together by many such ties, you may be better able to absorb local shocks, a bad winter, a disease outbreak, an accident that removes key hunters. Competition, in this sense, is not necessarily a matter of direct confrontation. It is a question of which strategy happens to buffer risk more effectively in a world of changing climates and unpredictable resources. Now imagine the landscape itself. Neanderthals and Homo sapiens favoured many of the same types of environments: river valleys, forest edges, the routes taken by reindeer, horses, or bison. Their stone tools were often designed to tackle similar tasks: butchering, hide scraping, woodworking. There would have been overlap in hunting territories, especially around resources that became crucial in certain seasons. Late winter and early spring, for example, are lean times in many ecosystems. Animals are thin, plant food scarce, and stored fat begins to run low. If two human populations share a region, these seasonal bottlenecks are when their needs most sharply intersect. Even without violent conflict, simple arithmetic comes into play. How many mouths can the local herd support when conditions are at their worst? If slightly more Homo sapiens bands are present in a region, or if their mobility allows them to converge more flexibly on the most productive spots, they may end up taking a larger share of the available prey during these critical periods. That leaves less margin for neighbouring Neanderthal groups. In a good year, both species might do well. In a string of bad years, one population may struggle more to replace losses. Over long stretches of time, even modest advantages in finding food, locating water, or sharing knowledge can compound. A population whose children survive just a little more often, or whose adults manage to avoid starvation in just a few more lean seasons, will gradually become more numerous. As their numbers rise, they can occupy more campsites, more hunting grounds, more winter shelters. This in turn further increases their resilience. None of this requires dramatic confrontations. It is the mathematics of survival playing out quietly, generation after generation. At the same time, it is unlikely that Neanderthals and Homo sapiens always used the land in exactly the same way. Ecologists talk about niches, the particular set of resources, behaviours, and conditions that a species relies on. Two similar species can sometimes coexist for long periods by partitioning that niche, using different prey, different microhabitats, or different seasons. There are hints that something like this may have happened in some regions. In a few sites, Neanderthals appear to have focused more heavily on certain kinds of animals, or to have used particular types of terrain more intensively, while Homo sapiens layers nearby show slightly different patterns. In some cases, Neanderthals seem particularly tied to rugged interior landscapes or specific cave systems, while our species appears more often in open areas or along different routes. These patterns are patchy and not always clear, but they allow us to imagine valleys where the two species did not constantly bump into each other. Perhaps Neanderthals concentrated on hunting in dense woodlands, tracking red deer and wild boar, while Homo sapiens groups increasingly followed reindeer across more open steppe. In such a scenario, direct confrontation could be rare, even if the broader regions overlapped. Coexistence might also have varied over time. For a few centuries a mosaic arrangement could hold: Neanderthal territories here, Homo sapiens territories there, some interbreeding at the edges, some cautious distance elsewhere. Then climate might shift, glaciers advance or retreat, rivers change course. A niche that once supported Neanderthals particularly well might shrink or move, while strategies favoured by Homo sapiens prove easier to adjust. In that moving puzzle of habitats and habits, what looks like competition does not need to be driven by hostility. It can be an indirect ecological process, each population following its own rules of movement, settlement, and social life, and the sum of those rules determining who thrives where. We also have to keep in mind scale. On the level of individual encounters, relationships could range from friendly exchange to tension to avoidance, much as happens between neighbouring groups in many small-scale societies today. But on the level of whole populations, what matters most is not any single meeting, but the slow accretion of many small demographic nudges. Slightly more children born here, slightly fewer surviving there, a band that splits successfully rather than failing, a migration that opens up new ground rather than ending in disaster. Over tens of thousands of years, those small differences can produce very large changes in who occupies the map. There may well have been episodes of violence, as there are in most human histories, but the broad pattern of Neanderthal disappearance does not require a story centered on conquest. It can be told, with equal plausibility, as a story of two closely related kinds of humans sharing overlapping worlds, subject to the same harsh climates and limited resources, but not equally buffered against random blows. In such a story, Neanderthals do not fall because they are simple or foolish, or because Homo sapiens are uniquely ruthless. They fade in relative numbers under the pressure of ordinary ecological forces, competition that is often indirect, shaped by weather and landscape, by the structure of social networks, and by the quiet arithmetic of births and deaths. By the time their traces vanish from the archaeological record, no single battle needs to have been fought, no final showdown staged. The outcome could be the result of many small imbalances, playing out in silence across ice-rimmed valleys and windswept plains, where both kinds of humans were simply trying to endure. When two long-separated human populations meet, there is another, quieter kind of competition that can unfold inside the body. Modern history gives us sobering examples. When Europeans and indigenous peoples of the Americas came into sustained contact, diseases like smallpox, measles, and influenza burned through communities that had never encountered them before. The pathogens were not new to the world, but they were new to those immune systems, and the effects were devastating. It is tempting to project that story straight back into the Ice Age, Homo sapiens carrying unfamiliar germs into Neanderthal territories, or Neanderthals harbouring microbes that our species had never seen, each group vulnerable to the other's invisible passengers. In principle, something like this could have happened. Any mammal population living for a long time in relative isolation will gradually accumulate its own suite of infectious diseases, some mild, some serious, many of them adapted to local conditions and host genetics. But here we run into the limits of what bones and stones can tell us. Viruses and many bacteria do not fossilize. Soft tissue decays. We very rarely see the classic signatures of infection etched into Neanderthal skeletons, and even when we do, pitting on a bone or signs of chronic inflammation, it is hard to say exactly which disease was responsible, or whether it had anything to do with contact with our species. So the idea of disease exchange between Neanderthals and Homo sapiens remains a hypothesis, not a proven chapter in their story. Where researchers have been able to probe more deeply is not into the pathogens, but into the defences. In recent years, fragments of Neanderthal DNA recovered from fossils have been compared to the genomes of living people. Some of the clearest overlaps occur in genes related to the immune system, especially those that help recognize and respond to invading microbes. Intriguingly, many modern humans, especially outside of Africa, carry versions of these immune-related genes that are very similar to or even clearly inherited from Neanderthals. In some cases, these Neanderthal-derived variants seem to boost resistance to particular infections or to help fine-tune inflammatory responses. In other cases, they appear to increase susceptibility to autoimmune disorders or allergies under modern conditions. From this, scientists cautiously infer that Neanderthals were not immunologically weak. They were, like us, the product of long coevolution with parasites, bacteria, and viruses in their environments. Their immune systems were tuned to the challenges of Ice Age Eurasia, when our species left Africa and moved into those same landscapes. Inheriting some of those locally tested immune variants through interbreeding may have been advantageous. At the same time, there may have been differences in how flexibly Neanderthal immune systems could respond to entirely new infections, or in how their bodies balanced the risks of underreaction and overreaction. Even small differences in the way fevers are regulated, or in how quickly certain immune cells ramp up, can change outcomes when a novel flu-like illness spreads through a small group. In tiny bands scattered across harsh terrain, the margin for error is thin. A disease that is survivable but debilitating, keeping adults weak, making children more vulnerable to hunger and cold, can still have major demographic consequences if it returns again and again, or if it strikes during already difficult seasons. Disease, in this broader sense, does not act alone, is braided tightly with other forms of stress. Neanderthals lived lives that, by all indications, were physically demanding. Their skeletons show thick muscle attachments, healed fractures, and joints that often display early wear. Hunting large animals at close quarters, hauling carcasses, chopping wood, and working stone all carry risk. Many individuals show evidence of surviving serious injuries, broken bones knit back together, skulls mended after heavy blows. Survival, though, comes at a cost. A body that is constantly repairing damage must divert energy and resources away from other needs: growth, reproduction, immune defenses. If a hunter with a partially healed leg must still go out in the snow to track game, their calorie needs rise at the very moment their capabilities are reduced. Layer on top of this the energy demands of simply staying warm. Neanderthals were well adapted to cold climates. Stocky builds, perhaps thick subcutaneous fat, behaviors and technologies that help them retain heat. But physics is relentless. Maintaining a high, stable body temperature in sub-freezing air requires a continual flow of calories. If food is abundant, this is manageable. If prey is scarce or a hunt fails, energy budgets tighten, and the immune system may quietly lose out. Repeated shortages, one bad winter after another, a stretch of summers when herds are thin or shift unexpectedly, can slowly drain reserves. Individuals who enter an illness already underweight or anemic, already coping with a healing wound or a pregnancy, face steeper odds. A respiratory infection that might have been a temporary setback in a well-fed, well-rested person can become deadly when combined with cold stress and hunger. Climate swings amplify all of this. The world Neanderthals knew was not uniformly frozen, it was a patchwork of shifting conditions. Over just a few centuries, a region might swing from relatively mild to brutally cold and then back again. Forests grew and shrank, grasslands advanced and retreated, rivers changed their courses. Each shift altered not only where food could be found, but also how predictable seasons felt. Unpredictability itself is a kind of stress. If herds migrate earlier than usual, if plant foods ripen at odd times, if ice lingers on a valley floor longer than expected, planning becomes harder. Camps might be moved more often, children carried farther, fires maintained for longer stretches. More wood must be gathered, more distances walked, more decisions made under strain. Under such conditions, even without new diseases arriving from afar, health can fray at the edges. Nutritional stress can weaken teeth and bones. Cold can worsen respiratory problems. Smoke from indoor fires, essential for warmth and cooking, can irritate lungs year after year. In cramped winter shelters, parasites and common infections may spread more easily between family members. Now fold in the possibility of disease exchange between two human species, meeting and mingling in this already challenging context. Perhaps a childhood illness that Homo sapiens children frequently survived, thanks in part to immune variants inherited from their African ancestors, struck Neanderthal children harder. Perhaps a pathogen that circulated harmlessly among Neanderthals caused more severe reactions in early Homo sapiens groups. We do not have direct proof of such scenarios. They remain informed speculations, anchored only loosely to the genetic hints and broad ecological patterns we can see. What we can say with more confidence is that Neanderthals, like all humans, were vulnerable to the combined weight of many small pressures. A slightly higher rate of injury, a slightly higher cost to staying warm, a slightly greater difficulty in buffering years of poor nutrition. These could quietly tilt the balance when illnesses, familiar or new, moved through a band. In the calm layers of sediment that now bury their campsites, these struggles leave only faint traces. A healed fracture here, a tooth with lines of childhood stress there, a cluster of individuals who died young. From those traces, and from the genetic echoes they left in us, we are left to imagine how disease, hardship, and hidden vulnerabilities may have joined competition and climate as part of the slow, uneven process by which their numbers dwindled, not as a single catastrophe, but as another thread in the web of challenges that any small, scattered population must navigate in a restless world. When we talk about the end of Neanderthals, it is easy to picture something dramatic, a final winter, a great plague, a decisive clash. Our minds are drawn to single causes, clear turning points, sharp edges in time, but in biology, endings often look very different. They creep rather than crash. They emerge from small imbalances repeated over and over, from numbers that quietly slide below thresholds that living systems need to sustain themselves. To understand how a species like the Neanderthals could fade away, it helps to think in terms of scale. Not continents, not entire ice sheets, but simple counts of bodies. By most estimates, Neanderthals never existed in vast crowds. Imagine all of Neanderthal Europe and Western Asia, from the Atlantic coasts to the foothills of Central Asia. Now imagine that spread not as teeming cities, but as scattered islands of people, a band here, another there, separated by forests, rivers, and stretches of empty, cold land. Some models suggest that, at any given time, the total Neanderthal population might have been only in the tens of thousands, perhaps even fewer. That is less than the number of people in a small modern town, dispersed over territories larger than many modern countries. Each group might have contained 20, 30, maybe 50 individuals. Births and deaths in such circumstances are not just private family events. They are demographic crossroads. In small populations, chance itself becomes a powerful force. A run of bad luck, a few difficult births, a hunting accident that takes out 2 prime adults, an illness that claims a nursing mother, can push a band down to numbers where every surviving child's fate matters enormously. Not because nature is suddenly crueler, but because there is no cushion of big numbers to absorb the blow. Biologists call this demographic stochasticity, the randomness of who lives and who dies from year to year. In a large population, these random wiggles average out. The curve looks smooth. In a tiny population, the curve can lurch and dive. A harsh winter that kills 5% of a large herd is a setback. The same winter that kills 5% of a group of 20 people is 1 adult, 1 child, 1 elder, and perhaps the only woman of childbearing age in that band. Over many generations, these small numerical accidents can accumulate. A line of descent might vanish, because the one person who could carry it forward happened to fall from a cliff, or succumb to an infection, or simply never have children. If something like this happens in isolated pockets again and again, a species can shrink without any single dramatic moment of extinction. Genetics adds another layer to this quiet math. When populations are small and scattered, mates are often chosen from a narrow circle: cousins, distant relatives, familiar families. Some level of this is normal in many human societies, ancient and modern, but in very small isolated groups, it can become common simply because there are few other options. This is where inbreeding enters the picture, not as a moral judgment, but as a biological process. When close relatives have children, the odds increase that both parents carry the same rare, harmful genetic variants. In their offspring, these variants can pair up and express themselves more strongly. Over time, this can lead to higher rates of genetic disorders, lower fertility, and subtle reductions in health and resilience. Ancient DNA extracted from Neanderthal bones gives hints that they sometimes lived under these constraints. One particularly well-studied individual from a cave in Siberia appears to have had parents who were closely related, perhaps as close as half-siblings or uncle and niece. Other genomes show signs of long-term small population sizes, stretches of DNA where there is very little variation, as if the same genetic stories were being told over and over, with few new twists. This does not mean that all Neanderthal groups were deeply inbred, or that inbreeding alone sealed their fate. What it suggests is a pattern of generally low genetic diversity, punctuated by episodes where local groups were especially small and isolated. In such conditions, harmful variants can silently build up, and beneficial new mutations have a harder time spreading through the population. Now imagine these genetic limits overlapping with social and geographic fragmentation. As climates shifted and landscapes changed, Neanderthal bands may have become more separated from one another. Valleys that were once easy corridors could turn into glacial dead ends. Forest belts could withdraw, leaving open ground that certain groups were less willing or less able to cross. Rivers could change course, carving new barriers. As connectivity drops, not only does genetic exchange slow, cultural exchange does too. Ideas, tools, and strategies that might have spread between groups, better hunting methods, more efficient ways to make fire, new ways of storing food, can become trapped in local pockets. One band might stumble upon a clever solution to a recurring problem, but if they seldom meet their neighbours, that solution dies with them if their line ends. Some researchers speak of cultural drift in this context, the random loss of practices and knowledge in small isolated communities, similar to how genes can drift in small populations. A particular style of stone tool, a method of tanning hides, a ritual around childbirth, any of these could disappear simply because the few individuals who knew them best failed to pass them on. Demographic models, built by plugging what we think we know about Neanderthal fertility, mortality, and group size into computer simulations, show how powerful these quiet processes can be. You do not need a comet impact or a supervolcano for Neanderthals to vanish in these models. You need birth rates that are just a little too low, death rates that are just a little too high, occasional bad years that push numbers down, and enough isolation that groups cannot easily rescue one another when they falter. Fold into these simulations a slowly expanding population of Homo sapiens, competing for some of the same resources, perhaps occasionally absorbing Neanderthal individuals through interbreeding, and the picture becomes even more precarious for Neanderthals. Their numbers can decline steadily, generation by generation, even if direct confrontations are rare and landscapes are shared for long stretches of time. It is important, though, to be honest about the limits of these models. They are not crystal balls. Each one rests on assumptions: how many children Neanderthal women typically had, how often infants survived, how frequently groups moved, how far they travelled to find mates. Many of these parameters are estimated from modern hunter-gatherers, from other primates, or from the sparse archaeological record. Change the inputs. A slightly higher birth rate here, a slightly better survival rate there, and the simulated Neanderthal world plays out differently. Some models suggest relatively rapid decline once certain thresholds are crossed. Others allow for long periods of stability, with local extinctions balanced by local recoveries, before a final tipping point. The truth may lie somewhere in between, or outside the range of what we have imagined so far. What these exercises do underline is that disappearance does not require a single villain or a single disastrous year. In a world of small numbers, chance, isolation, and the slow erosion of diversity, genetic and cultural, can work together to narrow the paths into the future. A species can find itself walking a ridge that grows gradually thinner until, almost imperceptibly, there is no ground left to walk. In the next part of this story, we turn from models and probabilities back to the Earth itself, to the actual sites where some of the last Neanderthals lived and died, and to the fragments of their presence that still anchor their final chapters in place. If we want to know how this story really ended, we have to leave the realm of graphs and computer models and return to solid things: caves, rock shelters, layers of soil, broken tools, fragments of bone. The final chapters of Neanderthal history are not written in a single place. They are scattered across a handful of sites, each offering a few paragraphs at most, sometimes only a sentence, sometimes only a word. One of the most often mentioned places is a rock shelter on the edge of the Iberian Peninsula, Gorham's Cave, in what is now Gibraltar. There, a series of deposits contain stone tools that archaeologists confidently attribute to Neanderthals. The tools belong to the Mousterian tradition, flake-based, carefully shaped, familiar from hundreds of other Neanderthal sites. For a while, dates from Gorham suggested that Neanderthals might have persisted in this southern refuge until about 28,000 years ago, long after they were thought to have vanished elsewhere. That number made headlines. It seemed to carve out a late survival pocket at Europe's southwestern tip, a last bastion clinging on as climates shifted and Homo sapiens spread. But as laboratory methods improved, the story changed. Researchers redated key layers using more refined radiocarbon techniques, better pre-treatments, and more cautious sampling. Contamination, tiny amounts of younger carbon seeping down into older sediments, had made the Neanderthal layers seem more recent than they really were. With that new work, the apparent last stand of Gorham's shifted backward in time. The Mousterian levels now appear to be older than 40,000 years, more in line with Neanderthal disappearances elsewhere in Europe. The spectacularly late date dissolved, leaving behind something quieter, an important site showing that Neanderthals occupied this coastal promontory, used its resources, left their tools and perhaps a few carved marks on the cave walls, but not an isolated enclave enduring almost into the era of painted caves and carved figurines. A similar rhythm of claim, excitement and revision has played out at other sites. In southern Spain and Portugal, a number of caves and rock shelters once seemed to contain very late Mousterian layers. Names like Zafaria, El Pendo and others entered the conversation as possible refugees where Neanderthals held out after disappearing farther north. There, too, improved dating methods and closer scrutiny of the stratigraphy have softened the edges. In some cases, layers thought to be late turned out to be mixed. Stone tools from older deposits had filtered down or been disturbed by animals, plant roots, or human activity long after the original occupation. In other cases, small bits of modern carbon had crept into ancient matrices, skewing early radiocarbon readings towards the present. Each revision feels, on the surface, like a disappointment, as if another piece of the puzzle has been taken away. But beneath that feeling is a different kind of progress. The more precisely we can tie tools and bones to secure dates and undisturbed layers, the narrower we make the window of uncertainty. The last Neanderthal does not move inexorably toward the present with each new find. Instead, the fog slowly clears, and we see that their final span overlaps deeply with the early presence of Homo sapiens, but probably does not brush as close to our own time as early hints suggested. There are also sites that anchor the other side of this overlap, places where Neanderthal remains, or characteristically Neanderthal tools, appear in layers closely followed, or even interlayered, with material linked to Homo sapiens. In the Levant, caves like Cabera and Amud preserve Neanderthal skeletons dating to roughly 50,000 years ago, earlier than the final European phases but crucial for understanding regional rhythms. Farther north and east, in the Altai region of Siberia, Denisova Cave and Chagyrskaya Cave have yielded Neanderthal bones and tools alongside those of another archaic population, the Denisovans, and later, modern humans. In these places, the problem is not the absence of evidence, but how to interpret layered, overlapping occupations. Stone tools of different traditions, Mousterian so-called transitional industries, and more blade-rich assemblages usually linked to Homo sapiens, can lie only centimetres apart. Did one group replace another swiftly, or did their occupations alternate over long spans like tides? Did they ever share the same landscapes at the same time? The dates, even when carefully obtained, often come with ranges of error that blur lines we would like to draw sharp. Some sites, such as Saint-Césaire and La Chapelle-aux-Saints in France, have provided relatively late Neanderthal skeletons, associated with tools and sometimes hints of deliberate burial. They show that Neanderthals were still very much themselves, anatomically and culturally distinctive, during the period when Homo sapiens were entering or re-entering Europe. Yet again, redating has nudged many of these finds into a narrower time frame around 40 to perhaps 45,000 years ago, rather than the much younger ages once proposed. Underlying all of this is a quiet but powerful source of distortion. Taphonomy, the processes that affect, remains from the moment they are left on the ground to the moment we uncover them. Bones rot, weather, dissolve in acidic soils. Sediments slump, wash away, or are reworked by animals burrowing and roots pushing. Fires burn away evidence of older occupations. In limestone caves, dripping water and slow calcite growth conceal some layers like time capsules while leaving others vulnerable. Preservation is not a neutral filter. Cold, dry caves in certain types of rock protect bones and tools far better than open-air camps on windy plains or riverbanks prone to flooding. Regions that happen to have many caves, parts of France, Spain and the Levant, loom large in the record, not necessarily because more Neanderthals lived there, but because more of their traces survived. Areas without good conditions for preservation may have hosted generations of Neanderthal life that left almost no durable mark we can now find. Because of this bias, the last known Neanderthal is almost certainly not the last living Neanderthal. It is simply the last one whose remains happen to be left in the right kind of place, in the right kind of soil, undisturbed long enough and lucky enough to be discovered and studied by us. When we say that Neanderthals probably disappeared from a region by a certain date, we are really saying that, so far, we have found no secure traces of them later than that point. Add to this the debates around specific artifacts and bones, and the picture becomes even more tentative. At some sites, a few teeth or bone fragments have been claimed as very late Neanderthals, only to be re-examined and reclassified as belonging to Homo sapiens, or to be deemed too fragmentary to assign confidently. Stone tools can be even trickier. Some industries in Europe, often labelled as transitional, contain features associated with both Neanderthals and modern humans. Different scholars read these assemblages differently. Some argue they reflect Neanderthals experimenting with new techniques. Others see them as the signature of incoming Homo sapiens, and still others suggest a blending of influences. These disagreements persist not because researchers are careless, but because the evidence is thin and the questions are subtle. A single bone, a handful of tools, a cluster of radiocarbon dates, each with its own margin of error. This is not the stuff of clear, unambiguous narratives. It is more like listening to a distant conversation through layers of static and trying to work out who is speaking and what they are saying. Yet out of this patchy, biased and contested record, some broad shapes do emerge. Across Europe and Western Asia, the youngest secure Neanderthal sites tend to cluster between roughly 50 and 40,000 years ago, with regional variation. In many areas, the last Neanderthal layers are followed, within a few thousand years, by the first clear appearances of Homo sapiens. In a few places, the two seem to overlap or interleave, suggesting times and spaces where both kinds of humans shared the same wider landscapes. The sites that anchor these conclusions are not grand monuments. They are often unassuming cavities in limestone, low rock overhangs, or eroded river terraces, but each of them holds a crucial sliver of the timeline: a hearth full of charcoal that can be dated, a tooth that carries Neanderthal DNA, a scatter of tools that shows who was napping stone on that patch of earth and when. Taken together, they remind us that the end of Neanderthals is not a single bold line on a chart. It is a series of local endings, staggered in time and space, each preserved only where conditions were kind and chance was generous. From these scattered anchors, we can begin to trace the outline of their final mosaic, a pattern we will follow more carefully in the next part of this story. If we step back from the individual caves and dates and let the pattern blur a little, a different kind of picture comes into view. It is not the image of a sudden catastrophe, or a single decisive encounter, or a last battle won or lost. It looks more like a patchwork of small pressures, overlapping in time, different in each region, but all slowly pushing the same way. One of those pressures was climate. Neanderthals had already weathered many swings between warmer and colder phases, but the period between about 50 and 30,000 years ago was unusually unstable. Temperatures in the North Atlantic region could shift dramatically within a few centuries, sometimes within the span of a few human lifetimes. Forests retreated and advanced. Open steppe spread, then was replaced by scrub and woodland, then opened again. For hunter-gatherers tied closely to large mammals and particular kinds of landscapes, this instability mattered. Herds of bison, horses and reindeer did not always move in predictable ways. A valley rich in game one generation might be poorer the next. Rivers shifted, floodplains rearranged, plant communities changed. None of this was instantly fatal. Neanderthals had the skills to adapt in many cases. But when environments become more erratic, every other vulnerability becomes a little sharper. A cold winter, an illness, a poor hunting season, these events, which a large, well-connected population can absorb, become more dangerous when the cushion of numbers is thin. Layered on top of climate stress was a new presence, Homo sapiens expanding into regions that Neanderthals had long occupied. This did not automatically mean open conflict. Competition can be quiet. It can look like two groups following the same herds, drawing from the same patches of flint, visiting the same water sources, noticing the same sheltered valleys. If modern humans brought slightly different hunting strategies, broader social networks, or more flexible ways of organizing space and labor, small advantages could add up over many generations. They might have tracked animals over longer distances, shared knowledge more widely between groups, or been quicker to shift to new prey or new plants when old resources thinned. In some places, Neanderthals may have held their ground for a long time. In others, they may have been edged into more marginal habitats, where life was simply harder. But the meeting of these two human kinds was not only a story of competition. The DNA evidence makes that clear. When Neanderthals and Homo sapiens overlapped in time and space, they sometimes had children together. Those children, and their descendants, are the reason that almost every person of non-African ancestry alive today carries a small percentage of Neanderthal genetic material. This mixing complicates what we mean by extinction. If a population disappears entirely, leaving no descendants and no genetic legacy, we can say it ended in a clean biological sense. That is what happened, as far as we can tell, to many other archaic humans. Neanderthals are different. As a distinct physical population, the broad-bodied, thick-browed people whose skeletons we recognize, they vanish from the fossil record around 40,000 years ago in most of their range. Their distinctive tool traditions fade and are replaced by others. We no longer find Neanderthal skulls in later layers, yet fragments of their DNA continue, recombined into the genomes of Homo sapiens. Some of those fragments influence our immune systems, our skin and hair, our susceptibility to certain diseases. Behaviours and ideas may also have flowed between groups, though those are much harder to trace. In that sense, Neanderthals are gone and not gone at the same time. The population ended, many of its building blocks did not. This makes the question, why did Neanderthals go extinct, more subtle than it first appears. Climate change alone does not seem sufficient. Modern humans alone do not tell the whole story. Disease may have played a role too. When long-separated populations meet, pathogens can leap between them. Even a modest difference in immunity can have outsized effects, especially in small scattered groups with little capacity to replace losses. And then there is demography, the quiet arithmetic of births and deaths. Neanderthals lived in relatively small bands, spread thinly across large territories. If their overall numbers were already low, and if survival to adulthood was precarious, it would not take dramatic events to tip the balance. A few generations of slightly lower birth rates, slightly higher child mortality, or slightly more frequent shortages of food could start a slow dwindling. In some regions, climate may have been the main stress, with modern humans arriving only after Neanderthal numbers were already weakened. In others, close overlap with Homo sapiens may have brought more intense competition, more interbreeding, and perhaps more exposure to new diseases. Some pockets might have faded largely through demographic bad luck, a run of poor years or a sequence of local misfortunes that left too few survivors to sustain a lineage. This is why archaeologists and paleogeneticists increasingly speak of a multiple pressures framework rather than searching for a single cause. The end of Neanderthals looks less like a single door slamming shut than like many small threads being cut at different times in different places until the fabric no longer holds together. Our ability to weigh these pressures is still limited by the thinness of the record. New discoveries could shift the balance. A well-preserved skeleton from a very late Neanderthal site with recoverable DNA might reveal signs of particular diseases or patterns of stress in bones and teeth that point to chronic hunger or hard labor. More ancient genomes, sampled from across their range and through time, could show whether Neanderthal population size was already declining before Homo sapiens appeared, or whether the downturn coincided with contact. Improved climate reconstructions, gleaned from ice cores, cave formations and lake sediments, might sharpen our sense of exactly what environmental changes Neanderthals faced in particular regions at particular times. Better dating of key layers could tell us more clearly whether modern humans arrived in an area when Neanderthals were still numerous, or only after they had already retreated. We may even discover new kinds of sites, frozen deposits in permafrost, caves not yet explored, submerged landscapes on now drowned continental shelves that capture moments we have not yet imagined, evidence of mixed communities, shared camps, or long-lasting boundary zones where Neanderthals and Homo sapiens coexisted in complex ways. For now, the safest picture is a mosaic one. In Western Europe, in the Levant, in the Caucasus, in Central Asia, the timeline of Neanderthal disappearance is not exactly the same, and the balance of causes may differ. But the overall direction is consistent. Under the combined weight of shifting climates, the arrival and spread of another adaptable human species, possible new diseases, and the inherent fragility of small scattered populations, Neanderthals dwindled. Not overnight, not everywhere at once, but gradually, region by region. As that happened, their last communities did not step off a cliff into oblivion. Some lines ended quietly, with no descendants. Others blurred into ours, their genes carried forward in children who no longer looked or lived exactly as their Neanderthal grandparents had. Somewhere in that blend of fading and merging lies the real end of their story, as much transformation as termination, a conclusion written not in a single moment, but in many small overlapping endings stretching over thousands of years. When we look back across this long, dim stretch of time, it can be tempting to see Neanderthals as a side branch, a rough draft, a story that failed. For much of the 20th century, that was the cartoon, heavy-browed brutes, shambling toward oblivion while real humans took the stage. The evidence we have now points to something different. Neanderthals were not a dead-end experiment drifting far from us on the human family tree. They were close cousins, close enough that our ancestors and theirs could meet, talk in whatever languages they had, share food and shelter, and sometimes have children together. For hundreds of thousands of years they weathered ice and thaw in a harsh landscape, making a living with skill and persistence. That alone deserves a quiet kind of respect. Some things we can say with reasonable confidence. Neanderthals made and used complex tools. They hunted large animals cooperatively. They cared for injured group members and placed their dead deliberately in the ground. They made use of pigments and ornaments, though how far that went into symbolic life is still debated. They shaped their surroundings with fire, shelters, and long-term knowledge of particular places. Their brains were at least as large as ours, and their genomes show no sign of a simple fatal flaw. Other questions remain open. How did they speak? What stories did they tell around their fires? How did they think about themselves, about other groups, about the animals they depended on? To what extent did they create art, music, or ritual that we would recognize as such? And how much of it has simply vanished in the erosion of deep time? We can infer and model and argue, but for now these remain gentle uncertainties, spaces where imagination has to sit alongside careful evidence. What is clear is that they have not vanished without a trace. They left part of themselves inside many of us, in strands of DNA passed quietly from parent to child. They left behind landscapes marked by their tools and hearths, bones bearing the signatures of their hands. They left questions that continue to guide new research, and a mirror in which we see that being human has never meant just one thing. As you lie here listening, perhaps far from the cold valleys they once walked, you are connected to that older world, by curiosity, by shared ancestry for some, and by the simple fact that our species is not, and never was, alone in its story. There were other ways to be human. Neanderthals were one of them. If you'd like to keep exploring these deep layers of our past, you can gently support this channel by liking this video, subscribing, and letting it play as you drift off on future nights. In the comments, you're warmly invited to share where in the world you're listening from and, if you like, what time it is there as you press play. Over the hours after this uploads, those messages build a kind of quiet map, dots of light scattered across the globe, people in many places pausing to think about the same ancient fires. For now, we leave the Neanderthals where they rest, in their caves and river valleys, in our genomes, and in our unfolding efforts to understand them. Their story is not finished, because each new discovery, each fresh question, adds another thread. When you're ready, you can follow those threads further, into other vanished worlds and other humankinds, knowing that deep history is always there, patient, unfinished, and waiting to be explored again when you wake.